Welcome back to this explainer. Today, we're diving straight into what is arguably the ultimate master key of finance. We're talking about the time value of money. It's the concept of how time literally changes the core value of your wealth. Whether you're steering corporate finances or just trying to optimize your own personal portfolio, wrapping your head around this is absolutely crucial for making smart, profitable moves. Okay, let's kick things off with a super simple question. It's a classic, but it reveals a massive truth about how money actually behaves. Would you rather have 100 rupees right now or wait a whole 10 years for that exact same 100 rupees? Instinctively, you know you want that cash today, right? But why? I mean, the number printed on the note is exactly the same. Well, the power behind that money shifts drastically depending on when it actually lands in your wallet. To figure out the why, here is our roadmap for this explainer. First, we'll hit the time value of money. Second, simple versus compound interest. Third, present and future value. Fourth, annuities and perpetuities explained. And finally, number 5, we'll wrap it all up with the sinking fund strategy. All right, jumping right into section 1, the time value of money. Why now is better than later. The foundational idea here is that a single unit of money is inherently worth more today than it will be tomorrow, period. In the finance world, we call this the present discounted value. Because maximizing your wealth isn't just about accumulating profit. It's heavily dependent on the timing of when that profit actually arrives. Every single financial decision you make today sends a very real ripple effect into your future. You see, there are 3 really aggressive forces constantly working to chew up the value of your future money. First up, inflation. Think about how much petrol you could buy 10 years ago compared to today. You instantly feel that, right? That's inflation eating away your purchasing power. Second is risk. Anytime you lend money out, there's always a default risk that you just won't get it back. And third, there's the opportunity cost of delay. If your cash is tied up waiting for some future payout, you're entirely missing out on the chance to invest it in something else right now. Moving right along to section 2, simple versus compound interest, the snowball effect. Now, to fight back against those 3 erosive forces we just talked about, we use interest. It's basically your compensation for parting with your cash for a while. But, and this is a big but, not all interest is created equal. This perfectly illustrates the massive divide between linear growth and exponential growth. With simple interest, your returns are calculated only on the exact amount you initially borrowed or lent. It's totally flat. But compound interest? That's a real game changer. That is where your money starts making its own money. It accrues on your initial principal plus all the interest you've previously earned that hasn't been paid out yet. Let's actually watch this math happen. Take a look at Mrs. X's setup here. She drops 2,000 rupees into an account at a 5% rate compounded annually. Year 1, she makes an easy $100. But notice year 2. That 5% is now calculated on 2,100, so she earns 105 rupees. By year 3, it's over 110 rupees. We are literally watching her ending principal snowball to over 2,315 rupees, just by stepping back and letting those earnings do the heavy lifting. So, section 3, present and future value, the time travel formulas. Let's see how that compounding idea builds into the ultimate translators of finance. These concepts let us calculate the exact worth of a specific pile of money at any precise moment in time. If we want to find the future value, meaning what the cash you hold today will grow into tomorrow, we take our present value and multiply it by 1 plus the interest rate, compounded by the amount of time. That's the exponent t. It gives you the exact cash value of your investment on a specific future date. And honestly, if you want to look backwards, we literally just run the exact same math in reverse. We take our future value and divide it by that same compounding factor. This tells us what a future sum is worth to us right now, in today's terms. In the biz, we call this discounting of future cash flow. Let's ground this with a concrete example. Picture this. You're checking out a fixed deposit, and it practically guarantees you a maturity value of exactly 26,620 rupees in 3 years. Sounds pretty great, right? But the real question is, how much should you actually be willing to pay for that fixed deposit today, assuming a prevailing interest rate of, say, 10%? Well, we just plug it into our present value formula. Divide that 26,620 by 1.1 to the power of 3, and boom, we get our answer. We realize that this shiny future fortune is worth exactly 20,000 rupees to us today. That is the true, mathematically time-adjusted price. Okay, section 4, annuities and perpetuities explained. Predictable cash flows. So far, we've only dealt with single lump sums. But what happens when cash flows become a recurring, highly predictable event?
Enter the annuity. An annuity is simply a steady series of equal cash flows happening at regular intervals over a set period. A textbook example would be a contract that promises to hand you exactly 5,000 rupees every single year for 10 solid years.
Now, calculating the present value of an annuity does get a tiny bit more complex. Because you have multiple payments dropping at different times, 1 year out, 2 years out, and so on, the underlying math uses a geometric progression. Basically, you're discounting every single one of those future payments back to today individually and then adding up the whole shebang. I know the formula looks intimidating, but trust me, it's really just the exact same present value formula we just used, simply applied over and over again to a sequence. But here is a wild thought. Annuities have a strict end date. What happens to all these geometric formulas when we're dealing with a timeline that is literally infinite? No end date, ever. That, my friends, is called a perpetuity, a cash flow that just keeps going indefinitely. A classic real-world example of this would be certain preference shares that are structured to pay out a fixed dividend forever. You'd probably think infinite time equals impossibly complex infinite math, right? Actually, it's the exact opposite. As time tends toward infinity, that massive geometric fraction zeroes out, and the equation collapses into something incredibly beautiful and simple. To find the present value of a perpetuity, you literally just divide the payment amount by the interest rate. Boom, done. Finally, Section 5, the sinking fund strategy, planning for the future. Let's pull all this theory together and actually use these tools proactively to crush a massive real-world financial target. Say hello to the sinking fund. You set one of these up when you know you're going to need a specific, usually pretty large chunk of change in the future, and you plan to build it up through regular investments. It basically hacks the future value of an annuity formula and runs it backwards to tell you precisely what you need to save today to hit your mark tomorrow. Let's run a scenario. Let's say your business absolutely needs 10 lakh rupees in exactly 5 years to upgrade some machinery, and we'll assume your investments are pulling in a solid 12% effective annual interest rate. So how much do you need to squirrel away every year? By firing up the sinking fund formula, we just divide your 10 lakh goal by our calculated compounding factor, and it spits out the exact number. You need to invest exactly 1,57,418 rupees every single year. Do that, and you'll hit your target flawlessly. And listen, if you're suddenly stressed about constantly having to crunch complex geometric progressions by hand, don't be. In the real world, finance pros just pull up standard valuation tables. You just line up your interest rate column with your year row, and boom, you instantly have your exact multiplier. It makes applying all this time value of money stuff incredibly fast and totally painless. As we wrap up this explainer, I really want you to take this away. Protecting your wealth from the erosion of time, inflation, and missed opportunities isn't just a strategy, it is your most fundamental financial duty. You now have the exact framework to see what future money is truly worth today. So I've got to ask, knowing that idle money is mathematically bleeding value by the second, what steps are you going to take today to make sure your time is actively working for you?